This video is on Lecture 9. Question 1. Different types of bond. In the previous lecture, we learned about ionic bonds. In this lecture, we will focus on covalent bonds. Which compound is an ionic bond? Circle all that apply. Ni and Cf are both not ionic bonds because they're both nonmetals. And FeCl is the only one that's a nonmetal and metal combined. So we know that that is our ionic bond. Question 2. When atoms need to fulfill the octet rule or duet, they may share electrons. The sharing of electrons between two atoms binds the atoms together. Such a bond is called a covalent bond. Co-sharing, valent meaning the valence, so sharing of valence electrons. Opposite of ionic bonding, when atoms are bonded covalently, they make up a new matter called a molecular compound or molecule. The sharing of electrons can be represented by an electron dot formula, also known as a Lewis structure, where electrons are either depicted as a bonding pair with a line, meaning two electrons shared between the two atoms, or a lone pair with two dots, meaning two electrons being exclusively on that one atom. So, the question, draw the Lewis structure for the following molecules. So, for A, it's CF4. So first, we take their valence electron numbers. Carbon has 4 valence electrons. It's in group 4. And fluorine has 7 valence electrons, and it's multiplied by that 4. So we do 7 times 4. Add those together, and you have 32 electrons. So we put that together by taking the carbon, which is the least electronegative, and bonding it with the fluorine. And after you do that, you just count the number of bonds that you have. So that's 2, 4, 6, 8. Carbon has now fulfilled its octet rule, so we need to go through and fulfill the fluorine's octet rule. So go and write all the dots here. And after you fill in all the dots around the fluorines, you count them out and make sure that you add up to 32. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 27, 28, 29, 30, 31, 32. So we have completed question A. So question B is pH3. So that's phosphorus. P has 5 valence electrons, and hydrogen has 1, and it's got the little 3 there, so we multiply it by 3. 5 plus 3 equals 8, so we have 8 electrons, and then we just add it together. Hydrogen only needs a duet, so we write the P and bond it just once, and you've fulfilled all of the hydrogens, but you can see here that there's only 2, 4, and 6 electrons, so we have 2 more. And the phosphorus has not completed its octet, so we just add 2 more. And we have completed B. Now for C, it is HCl. Chlorine has 7 valence electrons, and hydrogen still just has 1, so that's 8. And it'll be similar with the hydrogen, only has 1 bond, because it just needs to fulfill that duet. And then you have Cl. And that's 2. We need to fulfill it completely. 2, 4, 6, and 8. And now that is completed. Lastly, we have OF2. Oxygen has 6 valence electrons, and fluorine has 7, and we're multiplying it by 2, so that equals 14. So when we add that together, it equals 20 electrons. Now when we write this out, oxygen goes here because it's less electronegative. We add the fluorine, And then connect it and fulfill all of the octets. We have enough to go around, so we just draw it all in, and that's 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So question 3. The first step in naming a compound is to recognize whether it's an ionic or molecular compound. Refer to the flowchart in figure 6.6 to help you name the following molecular or ionic compounds. In order to name these, we decide if they're covalent or ionic. We know that this one is covalent because they're both nonmetals and they share their electrons. So that is a covalent. And this is carbon and fluorine. So, and fluorine has the number 4. You change fluorine to fluoride and write carbon fluoride. Oh, tetrafluoride. Tetrafluoride. This one is nitrogen and oxygen, and there's 2. So you change the second one to "ide" and you write nitrogen, and it's a di for 2 oxide. This one has the 2 right here. So with the same idea with the oxygen with di, you're going to write di-nitrogen oxide. Monoxide for 1. Dinitrogen monoxide. For D, we're going to write it's iron, which is a metal, so it's ionic. And we have a chloride. But since this is a metal, we're going to do it slightly differently. We take the 2 and we're going to write a Roman numeral 2. So we write iron, Roman numeral 2 in parentheses, and write chloride. Still keeping with the ides. So this has a 2 and a 3. It's covalent. And we're going to write di-nitrogen trifluoride. No, not fluoride. Sulfide. Dinitrogen trisulfide. This last one is nitrogen again, and iodine, and there's a 3, so that's tri. So we have nitrogen tri, and we're going to try and write iodide. I-O-D-I-D-E. And that is complete. On the other side, we have question 4. Although atoms may share electrons in a covalent bond, one atom may be more electron greedy than the other. The atom that is capable of attracting electrons more than the other is more electronegative atom. Electronegativity trends can be rationalized in the same manner as electron ionization trends. State the trend. So electronegativity on the periodic table of elements will increase as it goes from left to right on the periodic table, and we'll go from top to bottom. So the farther up towards the right you get, the more electronegative you get. circle the more electronegative atom. So when you look at a periodic table, which one is farther up to the right side of the periodic table? So right here we can see that phosphorus is lower than chlorine. So we're going to write chlorine. Sometimes you do need the chart in the book for it, but most of the time you can just look at the periodic table and guess. Fluorine is the most electronegative, so you can just circle that. Nitrogen and hydrogen, it's going to be nitrogen. Carbon and fluorine. The fluorine is the most electronegative, so it'll be that one. On this one's one you have to look up the value for, so nitrogen and iodine. Nitrogen is 3.0 and iodine is 2.5, so nitrogen wins. And carbon and oxygen will win because it is more electronegative. It's farther up to the right. In a covalent bond, the more electronegative atom can attract the electrons more, and thus the bond is more negative on one side than the other. This creates a dipole, two opposite ends, and the bond is further defined as a polar covalent bond. How is polar bond different from an ionic bond? The ionic bonds electrons are completely given and received, so you have a positive and negative. So in ionic, when the hydrogen gives up its one electron, that makes it a negative. When sodium gives up its one electron, it becomes negative. And when chlorine gains one of these electrons, it'll become a positive. So when NaCl goes together, it's an ionic bond. Polar means shared electrons, but unevenly. So it's a partial positive and negative. So one's more electronegative than the other. To annotate the partial positive and negative ends, we can draw with this symbol with the positive or negative sign with the weird looking S on top of each atom, and or draw the dipole of the bond with a plus sign connected to an arrow. For the following bonds, draw the partial charges in the dipole moment of the bond. In this one, A, we know that chlorine is more electronegative than phosphorus, so you can just draw this with a little sign at the end that shows that it's going that way. And you can do the interesting looking symbol like this. For this one, fluorine is more negative or electronegative, so we can just do that. And for this one, nitrogen is more electronegative, so you just do it in the opposite direction. Chlorine and fluorine, it goes towards fluorine because that's the most electronegative. Nitrogen and iodine, we know from the earlier question that it goes towards nitrogen. Carbon and oxygen, it goes towards oxygen. And we are done.